Hello and welcome to the Geospatial Centroid training video on working with tables using the Python Pandas library. This is part 2, the sequel. The first part was covered in another video. In this video, we'll be focusing again on pandas, and we will be taking a CSV file from an online source from this website right here, accessing that CSV file directly through the URL. We'll learn that we'll have to skip an extraneous row at the top, so we'll learn how to do that. We will do a quick review on how to report some basic information about the data, and then we'll get into some different things from the original. So we will subset the table for one county, subset the fields and pick and choose what columns we want to show and work with, retrieve unique values, and calculate mean values for each county using a technique called groupby. So let's get started. In this demo, we'll be walking through a Jupyter notebook, which I already have open, and we're writing all this code using Python, using pandas in a Jupyter notebook, but know that it can be also written in any IDE like PyCharm, Spider, or even idle. You can also use an ArcGIS notebook to do this same code, so there are a lot of different places that you could write this code. And the notebook file will be available to you in the comments as a link, so you can take a look and work with it yourself. Here again are the steps that we'll be taking, and in this case we will be working with data that's coming from an online source from this web page right here. So this is from NOAA, and it's snowfall and snow depth data, and there's a little interface here where you can pick what month and what state and what type of snow value you want. And then when you do that, over here, there's a way for you to download the data. So what we're going to be doing is actually grabbing the URL, if you take a look at the bottom, and that is how we can actually access it through our notebook. If you were to download it and open it in Excel, the data that we're getting is for March. It is snow depth for March for Colorado for 2021, and this is what it looks like. Notice that we have this extra top row, and that will mess you up. So we will look at how to fix that as well. Let's go back into here. So we have to import pandas as PD. We don't have to do the PD part, but we are. And then we're also going to import OS, which we will use later on. We're going to pass in the URL of that CSV that's coming from the NOAA website. And again, we're just going to grab that from here. So you can right click and say copy link address, and that's how we got it. Then we need to read that in as a data frame in pandas. So for that, we're going to give it a name. So df data frame will be equal to pd dot read underscore csv. Now normally you would just need to pass in the URL and that would be it, except that this time we need to skip that top row, otherwise it doesn't get read in properly. So what we need to do is after the URL, we want to say skip rows equals 1. What this will do is just jump right over that first row, and then it'll go right to our column headers and then the actual data. And it looks like it has been read in. Now for a quick review from what we covered in the first video. So we can print the first 5 rows using .head. We can enter another number in here if we choose to, if we want to print more than 5. And then we can also use a for loop or just df columns, print df columns, to print out the columns that are in the table. So here's my table. It has a lot of columns in it, 1 column for every day of the month. And then over here, we can see all the column names printed out. Now next, what if we wanted to get the total number of rows in the data frame? For that, we can just use len. Len of df. 721. So there are 721 records in this table. Now, if we take a look at the table here, we can see we have different counties. So let's pretend that we only want to work with Larimer County. How can we subset it to only pick out the ones where county equals Larimer? And that's what we'll do next in little step 3 here. When we do this, we're going to want to make a new data frame. So I'll just call that Larimer. Larimer will be equal to, our starting point will be the original data frame. And then from the original data frame, we want to point to it and basically do, oops, I forgot the dot, df.county, and basically do a query. So df.county equals Larimer. Then if we were to print out Larimer, it would only give us Larimer County. Another thing we can do is filter what columns we want back. There are 31 columns of snow data. Maybe we just want to like filter it out and just look at 2. So let's make a little list. We'll call it calls for columns, and we will type or paste in a list of the columns that we want. So let's say these are the only ones that we want. Now we can go and print Larimer again with that column filter in place. Now it's only giving us those ones. All right, think back to what we did 2 minutes ago. How can we find out how many records there are in just Larimer County? Now you may be noticing it says 96 rows right here. Yes, it does say that. But how can we get it programmatically? So remember, we can do len of our data frame, and we'll get 96. Recall from the first video where we did some more basic stuff, you can point to any column and point to that column and get the mean or the sum or the max or the min. So just for your memory, that's how you can do that right here. What if you wanted to get all of your stats for just Larimer? Remember, we also have dot describe. So let's do Larimer dot describe. Spell it correctly. So now we're getting our statistics for just Larimer County and not the whole state. Next up, let's go back to the original data frame, DF, that had all the counties for the whole state. Now let's say we want to get a list of all of the unique values from a column. So maybe we want to get all the unique counties that are in this table. For that, we can use the .unique method. So we might want to make a new output to hold it. So unique counties will be equal to our data frame dot the column name that you want to get the unique values for, dot unique. And that's how you would do that. And then you could return unique counties. And doing it like that, it gives you an array. It's not sorted. It's not very pretty. If you wanted it sorted alphabetically, it's actually a numpy array. So you would use numpy's .sort method, which of course would involve importing numpy. But then you could do print numpy.sort, and then the object that you want to sort, spelled correctly. And now you can see they're sorted. And another pop quiz for you. How can we get the number of counties? How many unique counties are there? Well, back to our old friend len. Let's print that. So we can do print len unique counties. And add all necessary parentheses. All right, so there's 63, which sounds about right. Now let's move on to our last big calculation here. Let's take a look back up at the original table up here. Notice that we have multiple entries for each county because each county has several different stations. Let's say we want to take or calculate an average elevation for each county. So what's the average elevation of all the snow stations within each county? To do that, we would use a method called groupby. So let's go back down here. The first thing you might want to do is just get a count. So you can pretty much just get a count of how many stations are in each county. That's what this is telling you. It's not really very well formatted. But let's say you want to do what we were just saying with the elevation. For that, you might want to make a new variable called elev. And we want to point to the data frame. And we want to call the groupby method. And we have to specify what field we want to group it by, and what field we want to summarize by, and what statistic we want to calculate. So that would be the county name is the field to group by, elevation. Elevation is the field that we want to calculate on. and then the statistic that we want is mean. So that should do it. And now let's do a print LF, and we will comment that out, and let's print it again. Now we have a list of each county and its average elevation for all the station values that are there. Likewise, we could calculate an average latitude or longitude. We could get like a mean center. If we had numeric values only, we could also calculate average or total snow depth for each station, for each county. Unfortunately, because these data were made funny, all the values are being treated as strings, not numbers, so that's a little bit extra tricky to get working. All right, and the last piece for this, what if you wanted to just get the average elevation for one county? To do something like that, you would need something like this. So here we have a print statement, average elevation for the county that we're telling it, and then this is how you would do it. We're going to take a value out of LF, and we're going to say LF.Larimer, and we want to round it to 2 decimal places. And then at the bottom, there's our statement, average elevation for Larimer, 5541.15. So LF is a complex object that gets returned from the groupby method, but then we can pick out pieces by pointing to the key, the index name, and then we can grab the value associated to it. So LF is not actually a dictionary, it's actually a pandas series type of object. You can think of it as similar to a dictionary where you have the key and the value. All right, so that's all we have for this demo. Like I said, those snow depth values are being read in as strings, and I have not yet quite figured out how to get it to work. I tried a few things to no avail. If anyone has ideas for things to try for that, go for it. I'd be happy to hear from you. If you're doing any work on the table that's going to make changes to the table, you might want to check that the table actually did change, and then you might want to save it out to its own CSV. We didn't make any changes in this case, so we don't really have to do that step, but if you wanted to take that URL and then turn that file name and modify the file name, this is one way that you could do it. All right, so if you want to learn more about pandas, there is no shortage of resources out there. So take a look at some of these and just the general internet. And yeah, happy coding. Thanks for watching.